Welcome again, CFED blog. Now, this time around, we are talking about stress and strain. Now, let's first of all pick stress. Now, stress is actually force, the ratio of force over area. But before I venture into this, I want to talk about the types of stress we have. Types of stress. Now, there are two types of stress. We have the tensile stress and the compressive stress. The tensile stress and the compressive stress. Now, this type of stress, this is more popular than this. The compressive stress, but I will explain what this thing means very well. Now, what is the tensile stress? Let's take, for instance, I have a string hunt. A string hunt. Now, if this string, I apply a load to it, initially, this is the length of the string, the original length. Now, if I apply a load to this string, this is a load applied to the string. Now, this new load has stretched the string from here to this point. Now, because it is stretched forward, it is called a tensile stress. Once it is stretched forward, it is called a tensile stress. But the reverse is the case for compressive stress. Instead of applying a load, stretching it. Now, what I now have is, I will try to compress it. Sometimes when you bring a spring and you use your hand, try to compress it. The stress on that string is called the compressive stress. But if you are trying to stretch it, it is called the tensile stress. The name does not matter, it just differs in demonstration. So whenever they ask you to calculate tensile stress or compressive stress, the formulas are the same. Now, what is stress? And this is what we call stress. Now, stress is defined as the ratio of the force applied on an elastic material to the area of the material. So our main focus is on the force and the area. The force applied, the ratio. Now, some textbook we call it is the force divided by the area of the elastic material. There is no difference. Division means ratio. So mathematically, the stress is given as force over area. That is what you call stress. Force over area. So when the force is being divided by the area, that is what you call stress. Now, this formula is applied to tensile stress and also to compressive stress. No matter the formula they use and the question they use, compressive or tensile stress, this is the formula to use. Force over area. We are going to see questions on this very soon. But before that, let me talk about strain. Strain is defined as the ratio of the extension of an elastic material to its original length. Extension over original length. Please let this not confuse you. So mathematically, what that simply means is that strain is equal to extension divided by original length. Remember, extension means change in the length, so which can also be written as the final length minus the original length divided by the original length. So this is what you call strain. Please note that while stress is force over area, strain is extension divided by the original length. Now, before we solve questions concerning the stress and strain, let's talk about Young modulus. Actually, the word modulus is someone's name. Now, we have different types of modulus. We have Young modulus, we have Shear modulus, and bulk modulus. We have three types of modulus. We have the Young modulus, we have the Shear modulus, and we have the bulk modulus. Now, our interest will be on this for the scope of our study. We're not going to talk, I'll just touch small thing about this. Now, shear modulus deals with area. The area focuses on the area of the elastic material, while bulk modulus talks about the volume of the elastic material. Young modulus deals with the length. Now, what is young modulus, which is the main thing we are going to treat for the scope of our study? And what is young modulus? Young modulus is defined as, so this is young modulus. Young modulus is defined as the ratio of the stress to the strain of an elastic material. Ratio means division. So young modulus simply means stress divided by strain. So we are going to use this to denote young modulus. Young modulus is equal to stress divided by strain. This is what young modulus is talking about. Now we now have our formula for stress. Stress is force over area divided by strain is extension over original length. So if you remove this, the division sign, you have to put multiplication sign and invert. So some textbook, if you don't want to solve separately, some textbook will combine and they will give you that this is equal to force over area. Removing this, you are putting multiplication. You have to invert what is divided. So it becomes original length divided by extension. So see, this is the formula for young modulus. Now, whenever you are solving young modulus, please take note of the unit. If the unit is in centimeter, please always convert to meter. If the unit is directly in meter, you solve straight. Now this is time to solve question concerning stress, strain, and young modulus. Okay, now this is the question. This one question will touch both the stress, the strain, and the young modulus. In this question, we are asked to calculate the young modulus of the material. So for further questions, you also go to your past question sections, whether Jamb or Waec, depending on the one you are preparing for, and also the exercises. In the exercises, you are going to see numerous questions concerning this. Okay, let's solve this question now. Now, they said a load of 20 Newton on a wire, the elastic material here is wire, of cross-sectional area, this, produces an extension of this. Calculate the young modulus of the material if its length is this. So we will bring out the parameters. I've told you that load is a type of force. So the force here is 20 Newton. Cross-sectional area A is 8 times 10 raised to the power minus 7 meters squared. Produces an extension. So the extension E is 10 raised to the power minus 4 meters. Then we now have our length, which is 3 meters. Now we can now calculate our young modulus. Now young modulus, from our previous explanation, means force over area times original length, which is this, divided by the extension. So we just need to put our numbers in. Now the force is 20 times the original length is 3 meters divided by our area is 8 times 10 raised to the power minus 7 times, then our extension is 10 raised to the power minus 4. Now, most of you preparing for Jamb, please, if you have 10 raised to power, solve them separately, then you divide this. What I mean by that is, bring these two together, we have 20 times 3 divided by 8. This is how you solve it. Now, this will come up, and once, remember the laws of indices in your mathematics, once this comes up, the sign changes. So this becomes times 10 raised to the power 7 times 10 raised to the power 4. So the negative sign will change. If what is here is positive, once we are bringing this together and bringing it up, it changes to what? Negative. Okay, now we divide. So dividing this through with your calculator, this will give you 7.5 times. Now law of indices, collect one of the bases, since the bases are equal, 10, plus we add a power, 7 plus 4 gives us 11. Now the unit is Newton. This is meter squared. This is meter, so when this cancels, it gives us the meter squared. So the unit of Young modulus is Newton per meter squared. So this is how to solve this question, very direct. Now from here now, let's go over to the next subtopic, which is the energy stored in an elastic material. Remember, for more questions, go to the exercise section. You can go to our YouTube channel. You are going to see so many questions on it.